Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's have a discussion on this past year question. Question of the year 2009, October-November paper, variance 12. So this question is about the chapter of coordinate geometry, combined with differentiation. So have a look at the question here. The diagram shows the line 2y equals to x plus 5 and the curve y equals to x squared minus 4x plus 7, and these two equations intersect at the points A and B. So for the part A, you are asked to find the x coordinates of the A and B. So how to find out the intersection point here, the point A and the point B? We will just need to solve these two equations simultaneously. Alright, so for the A, I'll just write it here. So solve this equation and this equation simultaneously is actually very easy. You just need to substitute the first equation into the second equation, since the first equation is already expressed in terms of x. So when you sub in, it's just 2 times the x squared minus 4x plus 7 equals to x plus 5. Then you just need to expand it, becomes 2x squared minus 8x plus 14 equals x plus 5. And then just move everything to the left hand side, then you get the equation of 2x squared minus 9x plus 9. It becomes a quadratic equation. So from your calculator, you will be able to get the answer of x equals to 3 and 3 over 2, which means the coordinate of the A should be the smaller one, 3 over 2. As the x coordinate of the B, it should be a 3. That's how we solve for the part A. As for the part B, you are asked to find the equation of the tangent to the curve at the point B. So the point B here, actually, they want you to find out this equation of the tangent, a straight line's equation. So you need to understand that for a curve, at different points, you have different gradient. So what's the gradient at the point B here? So how to find out the equation of the tangent here? Before we can find out the equation, we need to know what's the gradient of the tangent. So to find out the gradient of the tangent at the point B is actually dy dx. So you need to find out the dy dx by differentiating this equation. So the dy dx should be equals to 2x minus 4. And then at the point B, the x coordinate is equals to 3. So you need to substitute x equals to 3 to find out the gradient of the tangent at the point B, which means you need to substitute 2 times 3 minus 4, which is equals to 2. So the gradient of the tangent at the point B is equals to 2. So now you have the gradient and a coordinate. You need a coordinate for the point B. So for point B, you only have the x coordinate here, which is a 3. Then we'll need to find out the y coordinate. So the 3, you can either substitute into the curve or you can substitute into the straight line, because the point B actually lies on both the curve and the straight line. So if you substitute the 3 into the straight line to be easier, you will get y equals to 4. A 4 here. So which means the coordinate for the B, the B's coordinate is actually 3, 4. So now to form the equation of the tangent, you just need to substitute into this general formula, which is y minus y1 equals to mx minus x1. Or you can sub in to the other equation, which is y equals to mx plus c. So y minus, the y1 is a y coordinate of the b, which is a 4. Gradient is a 2. Then x minus the 3. So eventually the final answer will be y equals to 2x minus 2. That's the equation of the tangent to the curve at the point B. As for the part C, you're asked to find the acute angle in degrees correct to 1 decimal place between this tangent and the line 2y equals to x plus 5. So the tangent line is over here. The line 2y equals to x plus 5 is over here. So you're asked to find this angle, the angle between these two lines. So how to make use of the gradient to find the angle? You can actually use the formula m equals to tangent theta. The gradient of the line equals to tangent theta. So let me explain about this formula first. So let's say this is the y-axis, this is the x-axis, and let's say I have a line here. So for this line's gradient is m. If I let m equals to tangent theta, actually the theta is the angle between the line and the x-axis. So for now, go back to the question here, have a look at these two lines. I'll erase the rest so that you can see it clearly. Have a look at these two lines. Now you are asked to find the angle between these two lines, which is the theta here. So how to make use of the gradient of the two lines to find out the angle? So you notice that if by using this formula, the angle that you found is actually the angle between the line and the x-axis. So what we need to do now is to add in a line that is parallel to the x-axis here. And then, let's say you make use of this line's gradient and let it equals to tangent theta. So the angle that you made will be the angle between this line and the x-axis. So let me label it with another color, pink color, here. This big angle here. So if now you take another line and you let this line's gradient equals to tangent theta, you actually get the angle between this line and the x-axis, which is the smaller angle here. So now to find the angle between these two lines, which is the theta here, you just need to take the bigger angle minus the smaller angle. Then you get the angle between the two lines. Let's try this out. For the part C, for the first equation, which is the equation of the tangent that were formed in the part B, y equals to 2x minus 2. The gradient here is 2. So I'll let the gradient equals to tangent theta. So by using your calculator, you just need to find out the theta by finding the arctangent 2. Then you get the angle 63.43 degrees. And the other equation is 2y equals to x plus 5. So you need to rearrange it before you can get the gradient. So y equals to half x plus 5 over 2. So from here, we can see that the gradient is half. So half gradient equals to tangent theta. So the theta should be equals to 26.57 degrees. So how to find the angle between the two lines? Remember I mentioned here, you just need to take the bigger angle minus the smaller angle, then you get the angle in between the two lines, which is the theta that we are looking for. So I'll write this in blue color. So the theta, the angle that we are looking for, should be equal to the bigger angle minus the smaller angle. So 63.43 minus 26.57, you will eventually get 36.9 degree, correct to 1 decimal place as mentioned here. That's how we solve for the part C.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.